Good morning, this is your stats sensei, Mr. Spensey, and we're going to run a hypothesis test for two sample proportions. This is the treat me right scenario. A French study was conducted in the 1990s to compare the effectiveness of using an instrument called the cardio pump with the effectiveness of using traditional cardiopulmonary resuscitation or just CPR. Heart attack patients in participating cities were randomly assigned. Random assignment is important because that's going to change our conditions. That's going to eliminate one to being treated with either a cardio pump or CPR, depending on whether the individual's heart attack occurred on an even number day or an odd number day. Before the start of the study, a coin was tossed to determine which treatment, a cardio pump or CPR, was given on the even number days. The other treatment was given on the odd number days. In total, 754 patients were treated with the cardio pump and 37 survived. All right, so we can start filling some stuff out. So if we say this is our cardio pump, we know that we had a sample size of 754, and we know that 37 survived. So 37 out of 754. Let's divide that out real quickly. So 37 divided by 754 equals 0.049. And for CPR, 746 patients were treated with CPR and 15 survived. So 746, and this is 15. That seems like a pretty big difference to me. So 15 divided by 746, we'll have to run the test to see if it's statistically significant. But this is 2%. So 2% survived with this, with CPR. So this is 0.0201. All right, let's go ahead and start working on our hypothesis and our parameters. Our hypothesis is that there's no different. HO, P1 equals P2. That's very simple. But our alternative, we need to go back and do some looking real quickly. So we know we're going to start off with P1 and P2. But what are we supposed to do? Is the survival rate for the cardio pump greater than CPR? Oh, cardio pump is the first one. So P1 greater than CPR. Well, because we use those symbols, we need P1 and P2, we need to define them in context. So P1, let P1 equal the true population proportion of patients who survived using the cardio pump. Let P2 equal the true population proportion of patients who survived using CPR. All right. P hat C formula. Be careful. Make sure you're using the P hat C formula and not something else. So the P hat C formula is X1 plus X2 over N1 plus N2. And we can go ahead and plug in, and we know that P hat C equals a numerator of 37 plus 15 over a denominator of 754 plus 746. So 37 plus 15. And then 754 plus 746. So 52 divided by 1500. So what's 52 divided by 1500? And we get 0.03466. So P hat C is 0.0346. And we're going to need that. This will be super important for our conditions. Condition, this is going to be cardio pump. And this side over here will be CPR. 1, random assignment. And it was random assignment by a coin flip. So random assignment, and that was given. This is also going to be random assignment. And again, they did this by coin flip. That's how they use their randomization. Number 2, that's going to be 2 independent samples or 2 independent groups. We have that. 2 independent groups. And that's given. Three, the N is less than 10% condition. We don't have to do the third one. Why? Because it was random assignment. And if you read through this thing, they don't even have a population size. So when it's random assignment, you do not have to do the N is less than 10% condition. But you do have to do the normality condition. So is the sample size large enough? Now it's going to be N1 times P hat C and N1 times 1 minus P hat C. So I need to go take a look at this. What do I have? Well, my sample size was 754 and P hat C is 0.0346. So 754 times 0.0346. 754 times 0.0346 is 26. And that's greater than 10. So that's good. Then I need to go 754 times 1 minus 0.0346. So 754 parenthesis 1 minus 0.0346. And I get 720, almost 728. I'm going to call it 728 equals 728. And that's greater than 10. So that's good to go. Over here, number 4, N2 P hat C and N2 times 1 minus P hat C. Well, my sample size over here is 746. So 746 times, again, the same P hat C, 0.0346. So 746 times 0.0346 is 25.8. We'll just call it 26. It's approximately 26, and that's greater than 10. If it was less than 10, we'd worry about it, but since it's obviously greater, we're not going to. 746 times 1 minus 0.0346. 746 parenthesis 1 minus 0.0346. And that's about 720. Is approximately 720, and that's greater than 10. So clearly the sample is large enough here, and the sample is large enough here to use the normality condition. So our formula, probability that Z, well, what was our hypothesis? It was greater than. So the probability that Z is greater than P hat 1 minus P hat 2 P hat C times 1 minus P hat C over N1 plus P hat C times 1 minus P hat C over N2. Then I can go ahead and start plugging in. So this is the probability that Z is greater than, well, what's P hat C, or P hat 1? 0.0490? 0.0490 minus the 0.0201. Now I need to use P hat C, which is 0.0346, 0.0346. And let's go ahead and subtract that from 1. 1 minus 0.0346 is 0.9654. Over the sample size, the first one, 754, plus 0.0346 times 0.9654 over the second one, 746. All right. So let's start plugging in. Stat test. And this is a number 6, 2 proportion Z test. And we had 37 survive with the cardio pump out of 754. We had 15 survive out of 746 with CPR. And our alternative is a greater than, so that's what we need. And we calculate and we get the probability is of Z being greater than 3.066. Excuse me, not 3 point, but 3. Probability Z is greater than 3.0660. And we ended up with a p-value of 0.001. 0.0010. And it said use an alpha level of 0.01. Well, this is clearly less. So our decision is to reject the null. All right. So we're rejecting the null, so now we need to write our conclusion. And our conclusion is always going to be our p-value begins with that. Oops. Our p-value is 0.0010. Our decision, we reject HO. There is sufficient, there's enough evidence at alpha equal 0.01 to suggest that the true population proportion for cardio pump survival is, that's a greater than sign, greater than CPRs. All right, our p-value is 0.0010. We reject HO. There's sufficient evidence that alpha equal 0.01 to suggest that the true population proportion for cardio pump survival is greater than CPRs. In other words, we just said that cardio pump does a better job at saving heart attack victims than CPR does. All right, I appreciate you watching. I hope this helped, and I hope to see you on the next one. Thank you.